Okay, so on the Google Classroom you should have first of all this PowerPoint, and if you can't run a PowerPoint by yourself, then I'm recording this video for you. Then also we have Google Doc, which you can open up and pop me your name in your tutor group here. This is for making some notes as we go along. And then there's also a link to an app, which is a game for you to play if you've got time to practice. And I'll show you how to use all of these and also go through the PowerPoint now. So let's have a look at the PowerPoint. So Rutherford, as we saw before, came up with this model of the atom, which was called a nuclear model because his model, he came to the conclusion that most of the mass of the atom was concentrated in the center with a positive charge, and then there was a cloud of like electrons orbiting around the outside with a negative charge, and that most of the space here in the atom was actually empty space. Okay, so nucleus is where most of the mass is found. We now know that here we have protons and neutrons, and then the electrons are orbiting in shells, and there's very little mass here in the electrons. Most of the mass is concentrated in the nucleus. If you were to imagine this in real life, the nucleus of the atom was the size of a raisin, then the electrons will be orbiting around the outside of a sports stadium. So you can say that by far most of the atom is empty space. Nothing there. Most of the mass is concentrated in this tiny speck in the center, which is a nucleus, and the electrons are whizzing around really far away, hundreds of meters away, around the outside, and they will be like specks of dust. Okay. Now when we draw the atom, we draw it like this because we don't have space on our paper to draw it any other way. So this is not drawn to scale. So these basic building blocks that we've got in the atom, we've got the proton, neutron, and electron. The mass is tiny, so what we do instead of talking kilograms, we're going to just talk numbers. The mass of the proton, if it was 1, then the mass of the neutron would be 1. They're practically the same mass. The mass of the electron will be very close to 0. It's actually more like 1/2000th if the proton is 1. So it's about 2,000th the mass of the proton. So there's almost no mass in the electrons. Most of the mass is here in the protons and neutrons. Now the neutrons don't have electrical charge, they're not charged, but the protons are charged, which means the center of the nucleus is positive. The nucleus is positive, and electrons have negative charge. So the cloud of electrons that are around the outside are negatively charged, and these charges will balance out. So then the atom, the electrons number is going to match the proton number because the atom is going to pick up a number of electrons to equal out its positive charge, because the positive charge attracts negative charge. So on a normal atom, there'll be the same number of protons as there are neutrons, and the atom will have a charge of 0. Now, here we have a game, okay, and this game doesn't seem to be working. I'm not sure if I've just shown the answers or what I've done. But I'm not going to play that game. What I'd like you to do here is just skip to your Google Doc, and I'd like you to copy and paste into this table so that you've got the charge, the mass, and where you find the protons and neutrons and electrons. Okay, this is more than anything for making notes for yourselves. Then, as we move on through the PowerPoint, we'll get on to the next one, which I prefer you to work out by yourselves. So, move on. the atoms of each element have the same number of protons. That's what determines the element. So carbon atom always has 6 protons. If it has a different number of protons, it's not carbon. It's oxygen or nitrogen, it's a different element. So all atoms that have 1 proton are hydrogen. All atoms that have 17 protons are chlorine. All atoms that have 6 protons are carbon. And this is how we write the composition of the atom. Here we write how many protons are at the bottom, and then this is the chemical symbol: C for carbon, O for oxygen, Cl for chlorine, the same as on the periodic table if you do chemistry. And then the top number is the mass. So because the electrons don't really count for anything, there's hardly any mass there, this is just counting the number of protons and the number of neutrons. The atomic number is telling you how many protons there are, and also telling you how many electrons there are. So there's 6 protons, there'll be 6 electrons. And that's what makes carbon behave in chemistry in the way that it does, is the fact that it has 6 electrons attracted to it. But that's chemistry, and we're not interested in that. So here, the mass number is number of protons plus the number of neutrons. So if we just quickly go on, not all atoms or of an element like carbon have the same mass number. For example, carbon, we can find carbon 12, carbon 13, carbon 14. Always going to have the same number of protons because it's carbon. If it was a different number of protons, it wouldn't be carbon, it would be a different element. But the mass number being different, here in carbon 12 would have 6 protons and 6 neutrons. Carbon 13 would have 6 protons and 7 neutrons. And carbon 14 would have 6 protons and 8 neutrons. So each element might have different isotopes, and although they behave the same chemically, they have slightly different masses, each of the atoms. And later on we're going to see that some of these isotopes might not be stable. They might be unstable, and they might give out radiation when they decay into something else, into a different nucleus. So potassium here has 3 different isotopes that we found in nature: potassium 39, potassium 40, potassium 41. So at this point, you just skip back to your Google Doc, and I'd like you to fill in for these isotopes, which are written in different ways, the number of protons. So carbon has 6 protons, there, bottom number. Top number is 12, so it must have 6 neutrons, and because it has 6 protons, it can have 6 electrons. So there we've got the composition of this isotope of carbon. So we've got some different ones for you to work out, and then some ones that have been written in a slightly different way. And if you're missing information, you can always find information on the periodic table. So chemists do come in handy sometimes, but don't get used to that. Now finally, what we're going to do is we're going to put these keywords with their definitions in the Google Doc, okay, which is the same as what we just had on the slide. You just cut and paste in. So I've done the first one for you. Neutron is an uncharged particle found in the nucleus. Cut and paste into the table, and then once you've done that, you can hand this in to me, and that shows me that you've been through the PowerPoint. And if you want to go on and do a little bit more, then in this activity we also have a link to this app where you can play with different elements. For example, find the element with 8 protons. Now if I look at the periodic table, 1, 2, 3, 4, 5, 6, 7, 8 protons, I reckon that's going to be oxygen. Is it neutral or is it an ion? This is a bit of chemistry. If it's got 8 protons, got 8 electrons, it's neutral. Good. So here you can put yourself to the test with the periodic table and working out isotopes. Here we can put ourselves to test looking at the mass number, protons and neutrons. So the mass number has got to be 8 protons, 8 neutrons. Mass number is going to be 16. Wow, aren't I good at this? Here we've got a game of building atom. So here I can see I've got two things here in the center. I've got a proton and a neutron. So there's two there. And then I've got one proton, yeah, which is there. But I've got two electrons here. So that's not going to have a 0 charge, it's going to have a +1 charge. Oi, what am I going on about here? I don't think that's working properly. Oh, sorry, it is working properly. Let's go back, start over. So 6 protons, 6 neutrons, 6 electrons. The mass number is going to be 14. No, it's not. It's going to be 12. 6 plus 6. Okay, and it's going to have a 0 charge. Okay, getting better. Okay, and then finally just mystery 1. You've got to work out how many protons, neutrons, electrons there are. And it's just 5 quick questions. Check it yourself. See if you understand how you're getting on. Okay, if you've got any questions, pop them in the comments for this task. Okay, enjoy.